Hi there, I'm Katie Lohman with Senior Flexonics Pathway, and I'm here with Eric Bastian, one of our experienced engineers, to talk to you about the benefits of using a 2-ply testable bellow and how to test these bellows in the field to ensure that you and your maintenance team don't have a headache further down the road. So Eric, what is the benefit of using a 2-ply versus a 1-ply design?
Redundancy and early detection. A 2-ply testable bellows can operate through most failure events, which could force a shutdown with a 1-ply bellows. Hot or cold, a 2-ply test is one of the best measures of a bellow's health. Combine a testable bellows with a leak indicator, and you have an active system to mitigate unscheduled shutdowns and allowing the time to order replacement parts without expensive expedite charges.
Well, most of our expansion joints are critical parts in service that have to be 100% functional 24/7. So what's the best leak indicator available?
A visual leak indicator provides a simple, robust pass-fail indication that a bellows interply has failed that is visible from a distance.
Great. So if we want to test a bellows in the field that doesn't have a red top, what do we need?
Let's go to our maintenance shop to see what's in a typical 2-ply test kit.
I'm here with Mr. Bastian, and we're going to go over the 2-ply test kit that Seniors sells. He has available on our website to sell to you. You can call the 1-800 number and speak to any customer service rep and order it, or we can show you exactly what it entails and you can make your own at your site. So Mr. Bastian, would you mind showing us exactly what's in the kit?
Sure. So here first we have some common hand tools. We have crescent wrenches and a pipe wrench. These are mainly for disconnecting the installed fittings, valves on the 2-ply test board and then attaching your own valve block. So here we have the valve block, and it consists of a Schrader valve, a ball valve, a T with a pressure gauge on it, and usually we show 0 to 60 on this gauge. The important range is 0 to 15 we'll be working with. And then your connection. Now this is configured for a direct connection into the 2-ply test piping. We also have the option to connect a Teflon hose directly to the 2-ply test, and then you can have your valve block and pump away on a deck or over on a scaffold where it's a little more convenient. Now, after that, we have our pressure source. Here we've got a CO2 pump. These are commonly used for bikers. This is another type. This is a threaded connection. And those are used with just standard CO2 cartridges. And then also we have a bike pump. Now, one reason you would want to use CO2 rather than air on a 2-ply test is when you have a flammable media, such as a reactor overhead line or a spent catalyst standpipe expansion joint. Introducing air into the 2-ply space, there's always the chance that there's an interply leak, and so it's better that you can inject an inert gas rather than air, which can be flammable. Now the next items we have are fittings, and these are just the needed fittings to connect to the existing valve or port installed on the expansion joint. They can range from anywhere from an 1/8 inch to up to 3/4. And so we have a variety of fittings and connectors, adapters to allow you to connect from the pipe connection over to your valve block.
All right. And this is?
This is a red top. Now this is our visual leak indicator. And let me just pump it up for you, and you'll see that it provides a very vivid indication that's visible. If you would hold that.
Sure. And how far away can this be seen?
Easily up to 100 feet. You got that.
So these fittings are brass?
That's right. We use brass fittings to avoid galling or damaging the piping on the customer end on the bellows monitor ports. The brass is much softer, and so it won't cause, or it's less likely to cause damage to the threads. If you were to use carbon steel or stainless steel threads, then you'd run the risk of damaging those connections. All right, so once you have your fittings connected, then you pressurize the system, close the valve, and then you check for leaks with a soap solution or a bubble solution such as Snoop.
I'm here in our production facility with Mr. Bastian, and we're going to go over how to perform a two-ply test. So if you wouldn't mind, Eric, could you show us briefly how to do it?
Sure.
Thank
Pressure
you.
testing of bellows is a simple procedure. It requires several pieces of equipment. A pressure source, a gauge valve block, and the fittings required to connect to the two-ply test system.
Great. You going to show us how it's done?
No problem.
Thanks.
So you just hook up your pressure source to the Schrader valve on your valve block. Make sure it's open. And you just apply 15 psi. Then you release and close the valve.
Got it. Now, how often should this test be performed? And if you do see something, when do you need to panic? How often should it be done?
We recommend an alternating schedule of a hot inspection approximately 1 year prior to the planned turnaround, and then a follow-up cold inspection during the turnaround. This schedule allows time to plan based on the inspection findings.
And what should they do? What should a customer do if they see an indication in the field?
Depends on the type of leak indication. If you're reading a persistent pressure on the test port that matches the line pressure, then the inner ply has a leak. Depending on the consequence of bellows failure and a customer's risk tolerance, they may only order a replacement part to be ready to install at their next shutdown. For the most critical applications, a clamshell bellows can be installed online to restore the bellows redundancy. If the leak is a passive type where the pressure test leaks down to 0 over time, then the first action is attempt to identify the location of the leak. Often fittings, valves, and the two-ply test system are the leak source. Just tightening, retaping the threaded connections is often enough to solve an initial leak. The flow test port is often located 180 degrees from the main test port on a bellows, which is a common leak source. If the leak is isolated within the bellows, it is likely a leak in the outer ply or in the monitor tube welds. Many times these can be repaired online if they can be found, or at the next shutdown when the bellows can be thoroughly liquid penetrant examined.
Now, this gauge is a little difficult to read. Is there something out there that's easier to read and more accessible to see at a distance? We have a product like that?
Our visual indicator called a red top is very useful for continuous monitoring while online. And it'll provide, if the internal ply space pressurizes, it'll provide you a visual indication that's visible from up to 100 feet away.
Great.
As you can see, the pressure gauge can be difficult to read, especially in a crowded refinery environment where there's gauges everywhere.
Right.